Okay, so in this class, we'll complete the remaining portion of 8.4. These are not tests. You write it as we explain together. You write on your notebook, okay? The first one here, the first question, number 1. Let us see there. Express the trigonometric ratios of sine A and sec A, tan A in terms of cot A. So every of these three you have to change in the form of cot A, in terms of cot A. So let us begin with the first one, sine A. We know there is one formula which says 1 by cosec A. We are familiar with this reciprocal ratio, so the formula is this, right? So here, how do we change this to in terms of cot A? Now let us go down and see here. We have been doing this formula very familiar to us now. Cosec square A is equal to 1 plus cot square A, right? So if you remove this square here, then we'll get a root here, 1 plus cot square A, right? This one is now same as this, so we can now use this formula. Then we are getting in terms of cot, you see cot square A. So that's your first answer. We have expressed sine A in terms of cot square A in the form of 1 by root over 1 plus cot square A. Okay, then the next one here, sec. We have to do the second one. The second one is sec A. How do we change this sec to cot? That's the question, right? So we know sec square A1 formula. Let us just begin from here. 1 plus tan square. Very familiar with us. Let us begin with what we're familiar with. But they're asking us for sec A. So let us change the square to sec A. And root will come over here. 1 plus tan square A. But they're asking you to express sec A in terms of cot, not tan. So let's try to change this. Tan A we know is 1 by cot A. So tan square A likewise will be 1 by cot square A. Common sense, right? And root should cover everything. Now look carefully here. Cot square A into 1 is cot square A. Then plus 1. Since we have multiplied here, long line should cover up to there. And the LCM is cot square A. And root should come, right? And the next step here, that will be equal to, this one we cannot remove. So we'll just write it under root cot square A plus 1 or 1 plus cot square A, same thing. So equal sign is usually put near the line. So let's put it. Now cot square A can come out of the root as single. Cot A, no more root, right? So everything is in terms of cot now. That's what the question is saying, okay? Next here, the final one, tan A. That should be very easy. Tan A in terms of cot A is very direct formula. We have 1 by cot A. So second answer, third answer, first answer. Question number 1 done, right? Let's go to question number 2. Here, question number 2. Let me read the question for us. Write all the trigonometric ratios of angle A in terms of sec A. All the other trigonometric ratios. Now let's just to make it understand, let's write down sine A. What are the 6? There are only 6 trigonometric ratios. Sine A, cos A, tan A, cot A, sec A, and cosec A. 6. 1, 2, 3, 4, 5, 6. Except this one, which is already given. The other means 1, 2, 3, 4, 5. Okay. So let's start with the first one for sine A. And in terms of sec A. So let us start with that. Now first one, we know one formula very common. Sine square A is 1 minus cos square A. The first one. Let us say 1. Put a subheading ourselves. So they're asking for sine. This one, we're doing this one, okay? So square remove means root over 1 minus cos square A. But they're telling us to change it in terms of sec, everything now. So how do we do that? Cos A is 1 by sec A. So cos square A will be 1 by sec square A, and root should cover everything. Now sec square into 1 is sec square A minus 1. Long line because we have multiplied by sec square A. Root should cover everything. Now we got pretty much everything in terms of sec. So we just need to simplify it. Sec square a minus 1 we can remove. So just put under root. And this sec square a can come out of the root as single. So everything is sine a. First one is expressed in terms of everything in form of sec. Sec square, root over sec square a minus 1 by sec a. So in terms of sec. Like that, we have to express the next one also in terms of sec. That is cos. Cos a is 1 by sec a. Very direct, very easy. This one is quite easy, right? Then number 2, this is. The third one, the other trigonometric ratio means there will be 5. Except sec. So here, next one is this also done. So go to 10a. Now 10 square a is equal to sec square a minus 1. We know this formula, right? So write that down. So we have to find 10a, not 10 square. So right here, 10a equal to root over sec square a minus 1. We have expressed it in terms of 10a in terms of sec again, in the form of root over sec square a minus 1. So now cot. Now we know here, number 4, cot a is equal to 1 by 10a, right? 10a. So here we will use this formula 1 divided by, see here, 10 square a is sec square a minus 1, but 10a is root over. So use this formula in place of this, root over sec square a minus 1. So cot also done. Finally cosec, right? The fifth one, find all the other trigonometric ratios in terms of sec a means the remaining 5 out of the 6. So cosec. How do we? Cosec square a is equal to 1 plus cot square a. 1 plus, like this also we can do, cot square a, right? Now here, if you remove this one, here, this one here, cosec, okay, one more, okay, you can remove it, cosec square, then root will come over this one, 1 plus cot square a, right? Then let us continue. Here, as we continue, that will be equal to 1 plus cot a is 1 by 10a. We have to express everything in terms of sec a, right? So yes, so this one also, yes, we can express in terms of 1 plus cot square a. Okay, so 1 plus 10 square a is sec square a. Okay, so 10 square a, right? Root over, see, 1 plus 1 by, so this one. Then here we can do like this, 10 square into 1 is 10 square a plus 1, long line, divided by LCM is 10 square a, right? Now we have to change everything in terms of sec, which is quite easy now. Root over 10 square a plus 1 we know by formula is sec square a, and 10 square a we can change it to sec square a minus 1 formula, right? Then here sec square a can come out of the root as sec a. This one we cannot remove, so root still there, sec square a minus 1. So this will be your answer for sec a by sec square a minus 1, the answer for cos a in terms of sec. So all the 5 we found out in terms of sec in the final step. So that is our answer, number 2. Then finally number 3, question number 3. So let us go there. Number 3. Okay, so number 3 here, the last question in this class, and we'll continue the remaining questions in the next class, which is also not test. Okay, 3, evaluate, means find the value 1. Let us do that. Sine square 65 degree plus 63 degree plus cos square, sine square again, sine square 27 degree divided by cos square 17 degree, cos square 17 degree plus cos square 73 degree. Now 63 plus 27 we know is 90. So they are complementary. 17 plus 70 also. So we have to use the complementary ratios. In the previous class we have done this. Let us change any one you like. Maybe you can change this smaller one or bigger one, up to you. Then you keep the bigger one same, sine 60 degree, and here we know one formula, sine A is equal to cos 90 degree minus A. We use this formula when the two angles are complementary. That means together they are making 90, then we can use that formula. So sine A here is 27. So there will be cos 90 minus 27. So we write here cos 90 degree minus A, our A here. So we decided to change this. Down here also we can change this one, smaller one or bigger one, also up to you. Then formula for cos A we have to use is sine 90 degree minus A. We use, as I said, we can use this when the two are making 90. And here also 73 plus 17 is 90. So we can use that formula. So this is sine square, because sine A, cos A is sine 90 degree minus A, means cos square A will be sine square 90 degree. So sine square 90 degree minus our A here is 17 degree. And we decided therefore not to change this, cos square same as it is remain. Then here, next step, sine square 63 degree plus cos, sine square, so here also square, So cos 90 degree minus 27, if you do, surely you will get here 3 and 63. So square 63 degree. Likewise, sine 90 minus 17 you do, you will get this one, 73. So sine square 73 plus cos square 73 degree. Now we can use this formula now, very common to us. Both are same, 63 means both are like AA. So sine square 63 plus cos square 63 is like sine square A plus cos square A, which is we know is 1. Down here sine square 73 plus cos square 73, 1. So the value is 1. So the value of this expression is finally coming out as 1 in the simplified form. Okay, this is called evaluate, find the value. Now let's go and do the second one. One more is there under subheading 3. So here, sine 25 degree, sine 25 degree, okay, sine 25 degree here into cos 65 degree, cos 65 degree plus sine cos 25 degree into sine 65 degree. This is given to us and we have to find the value of this. So let us do that. Now we can decide to change which one you like. Bigger or smaller is up to you. Together they are 90 again, you see. 65 plus 25. That's right, 90. So they are complementary, so we can use those complementary formulas. Maybe you can change the smaller one then. Sine A is, let's use this formula, cos 90 degree minus A. Close bracket. Don't forget to put the degrees into this one. We decided not to change, then 65 will not touch. And cos A is sine 90 minus A. 90 degree minus A is 25. Therefore, into this one we decided not to touch. So we keep it like that. Okay. Then next step. Here, cos 90 minus 25 is surely 65 degree, right? So this is same 65 degree plus cos 90 minus 25 is again 65 degree into here. Here we made a mistake. See, cos A is sine 90 minus theta. Sine. So this is sine, and then 90 minus 25 is 65 into here also sine 65 degree. So we can just simple case of cos into cos is cos square 65 degree plus sine into sine is sine square 65 degrees. So cos square A plus sin square A, both are same again now. 1. Okay. So that concludes these 3 questions. In the next class, we'll do the remaining exercises and the examples. So everything is concluded there. Okay.